Hi, everyone. Thank you so much for joining us today. We'll get started in just a moment. Thank you. Hi, everyone. Thank you so much for joining us for Firmware Integrity Measurements and Attestation webinar hosted by the UEFI Forum. I would like to introduce you to our presenter, Dick Wilkins, who's the Principal Technology Liaison at Phoenix Technologies. And then I'll go ahead and pass it off to Dick.
Well, thank you very much. First, I'd just like to welcome everybody to this webinar. It's good to be able to greet everyone despite our pandemic. This is the last presentation that was planned for our spring PlugFest educational event, and I want to let everybody know that we intend to continue this series for the foreseeable future, possibly even if we're able to continue and go back to meeting face-to-face at our PlugFest events. We think that it's a really good outreach opportunity. That said, this is the last of our pre-planned presentations. We have a few more that have been proposed and queued up. If any of you out there would like to make a presentation to this group, to people of interest to the UEFI organization, please feel free to reach out to the Industry Communications Working Group and make a proposal for a talk. We would love to give you that opportunity and that stage to say what you'd like to going forward. But for today, we need to talk about firmware stuff, firmware measurements and things. We always have to have the legal slide that our lawyers make us put on the screen. So we have done that. You have seen it. It will be in the package of slides afterwards. Now let's get on to the real meat here. What are we going to talk about? We're going to talk about the NIST SP 800-155, what's happening with that, why it wasn't implemented, what NIST has done, and what the Trusted Computing Group and other groups are doing in this space, and why you all should care about it, and then a call to action, and then any questions you might have. So that's the agenda for today. First of all, what is 800-155? Well, the National Institute of Standards and Technology, part of the Commerce Department of the United States government, published one of their special publication drafts called BIOS Integrity Measurement Guidelines back in December 2011, almost 9 years ago now. It described a process for checking or measuring the firmware on a platform and attempting to detect any unauthorized modifications that might affect the security of the platform. It detects changes to code, changes to configuration parameters, changes to the hardware configuration, etc., and then demonstrates how that can be passed to an external verifier. They refer to it as a Measurement Assessment Authority, an MAA, but the term verifier has become in more common use since the 9 years since this was originally published. Then they also go on to discuss remediation steps if a system is found to be the configuration changed or damaged in some way. They talk about how it can be quarantined on a private subnet, for example, also how scripts can be run to attempt to recover the configuration and restore it to normal use, etc. The problem is it's not been widely accepted or implemented in the marketplace. Everybody seemed to think that this is a great idea, great and valuable, particularly in the enterprise and government spaces, that have each system check itself as it boots and joins the network, communicate the configuration measurements to some external authority, have that verified, and then only after it's been verified as undamaged and that it's configured correctly, etc., then be allowed to join the network at large. But the problem is a bunch of OEMs and others, platform firmware vendors, etc., created prototypes of how this might work, but it hasn't actually been implemented and deployed into the field very much. And some possibilities of why this is true. The initial version was focused on BIOS, they called it. We now like to call that platform firmware versus BIOS, but still it was focused very much on the firmware and the firmware's configuration. And there are a lot of other things that affect the security of a platform, not just the code and possibly the configuration of that code. In our case, EFI code and EFI variables. So also they mention TPM hardware that comes from the Trusted Computing Group, the specifications for it a lot in that, about how the measurements could be done. And not everyone has a TPM or chooses to have a TPM or chooses to use the TPM, that in some geographies they're not even allowed. The spec that was, or the guidelines that were proposed by NIST were focused quite a bit on TPMs. Plus, it was only like 30 pages long without a lot of detail, and so folks felt like, gee, how do I implement this successfully? There's not enough detail here to be successful. And then I know that's a bit of an oxymoron between the discontinuity between too specific and not enough specific details, but both were true at the same time, which caused all kinds of problems. Then, as people started digging into this and doing prototypes, they discovered there was all kinds of levels of complexity that weren't addressed in the initial guidelines. How does everybody communicate this? How do we store and provide the known good measurements? How do we verify things in an environment and a heterogeneous environment with all kinds of devices and operating systems and suppliers of hardware and supplier of measurements, etc.? How do we coordinate this whole thing? And there were very few standards in existence for people to create cooperating facilities. It was very difficult to come up with a solution that would work across multiple different enterprises. So NIST was a little disturbed by the fact that nobody was doing what they asked them to. Nobody was following their guidelines. So they approached the Trusted Computing Group and suggested a collaboration to try and come up with a solution that would be implementable across the industry, and asked TCG to consider developing detailed specifications for how to meet the guidelines in 800-155. At least provide an example implementation that would meet the guidelines in 800-155, and not that that was the only way to do it, but here was one successful way to implement things. As part of that, NIST contributed the actual text, released their copyright of SP 800-155 to TCG as a starting point. So you can take anything you want out of our document and use it in your specifications and use it as a starting point. Then they said that after TCG published their specs and described how you could actually implement 800-155, then NIST is likely to refresh 800-155 and will then point to the TCG specs as an implementation example. So TCG decided that that was a good idea, and they took the mantle on to try and produce specifications. And the various TCG working groups went off to create and design specifications for how this might actually be implemented. A number of working groups are involved: the PC client working group, the server working group, Attestation working group that was created largely in response to this work, their existing infrastructure working group, the network communications working group, and the DICE working group that deals with small configuration devices that may not support a TPM in their environment and may not have complex encryption capabilities, but still need to provide some of the same capabilities to ensure that they're safely on the network. Also, at the same time, there's a lot of interest in this topic. The industry, the community out there of people who build large computer networks with lots of devices want this capability. They want the devices to be able to attest to their status before they join a network, and then deal with the fact when they don't, etc. So a bunch of other international standards bodies have been working on this same solution space. The IETF that does networking, the DMTF, now I guess they've stopped calling themselves the Distributed Management Task Force, but they just go by their acronym of DMTF. The Open Compute Project, the FIDO Alliance, it does identity verifications, World Wide Web Consortium, Global Platform, etc. And I'm sure I'm missing some. So let's step back for a moment and say, well, how is this different than good old UEFI secure boot? We do that already. It's become pretty standard in the PC and mobile device, large mobile device market, and in many servers as well. It's pretty widely accepted, and everybody in this, probably listening to this call, knows about it and probably is pretty familiar with it. But just as a quick reminder, as a system boots up, each section of code verifies the signature of the next code about to be executed. And if that code has been altered, damaged, something has gone wrong with it, then it will not be executed. It also maintains a database of forbidden code signatures that would have been valid otherwise, typically code that was previously signed and allowed to run on a system, but then at a later time was found to have a vulnerability, and so it was marked as non-executable. Note, we have, over the last, since July, we have posted 2 updates to the DBX database that disable additional pieces of code from being executable as part of the secure boot. But bottom line, what ends up happening is any code that's been damaged or altered, will not execute. And of course, depending on exactly what that code does, the system may not completely boot. It may stall at that point. Depending on, if it was an option ROM on a device that's not critical to the boot path, the system may boot just fine. But in many cases, the system will just stop and not boot at all. TCG, on the other hand, had long proposed, and has documentation in existence for something they refer to as measured boot. It's similar to what secured boot does, but not the same. It starts, and by the way, I want to thank TCG for the use of their drawings here in this slide deck. This comes directly from their spec. So when a system starts up from power on, or comes out of a sleep state or whatever, it initializes some platform configuration registers to 0, and then it goes through a similar process to what secure boot does, in that, and in fact, in many cases, it is the same process, and it checks the signature, hashes code segments before they're executed, and takes those hashes of those and loads them into PCRs via an operation they refer to as an extend, where a hash of code and configuration variables and other materials that are of interest are hashed together into a value, and then as part of the extend, they are hashed with the existing value of the PCR, and a new PCR value is created. Also, at the same time, they log what it is they measured, what the values were that were measured, and there's no evaluation at this point on whether that's good or bad. It's not comparing it against anything. It's just storing a summary in a PCR and a listing of exactly what was measured and what values were generated in an event log. That it steps through the boot process pretty much in the same way that the UEFI secure boot happens, going step by step, but it measures each step along the way and stores those values in the PCRs and the event log so that they can be evaluated later. This has been the measured boot process from TCG right along, and it's seen as very valuable in that it can be used in two ways. One, the way it's commonly used today is once you've completed the boot process, then you can store critical data like encryption keys, for example, the bootlocker key, in protected memory in the TPM, and store it against the values in PCRs, and then you only can release that key on a future boot if the PCR is matched. So the encryption data or encryption key is stored and protected in that can only be read out if the PCR is matched what was when it was stored. So it protects the encryption key from damaged or altered code. It can also obviously be used, the PCR values can be checked to see if they matched by an external verifier, and if they don't match, the event log can be uploaded and evaluated as well. And so here's another one, a picture from their spec, and this shows the verification process. And show on the left-hand side, a platform generates PCR values and an event log as it boots, then sends it to a verifier, some external to the system itself. The verifier then pulls from a golden storage or storage location somewhere that's protected a set of golden measurements that are known to be valid, and can compare. If the PCRs all match, it can do that very quickly, and if the PCRs match, then there's no need to go any further. The system is fine. If they don't match, there could be a lot of causes for the PCRs to not match the previous ones, but potentially still be a valid system that hasn't been compromised security-wise. So the verifier can then walk through the event log, checking to see the current event log against a saved golden event log, and validate where things went wrong, why the PCRs are different. And it can make a rational decision at that point, saying, yes, the PCRs are different, but the difference between the platform now and the platform when we saved the golden measurements is something non-critical, doesn't make the system vulnerable security. So I'll go ahead and say that I'm okay with the verification of this process. So it gives us some flexibility. So it doesn't just compare PCRs and say, nope, PCRs don't match. It's a corrupt system. But in the process of creating this step-by-step process, many levels of complexity started to appear. Back to the same reason why 800.155 wasn't implemented in the first place. The enterprises don't just care about PCs and servers. There are a lot of things, like servers have baseboard management controllers or BMCs or management controllers generally. They care about those. They care about appliances, mobile devices that may not be running UEFI, IoT devices, including DICE-style devices that may not have a TPM or even the capability of doing full encryption. So how do we identify those devices when they appear on the network? How do we verify that they are appropriate to join our network, et cetera? So continuing with the levels of complexity, sometimes the supply chain needs to be verified. When an enterprise receives a bunch of new computers, as an enterprise receives a bunch of new computers, they need to verify that what they received was what the OEM intended, what was built in their factory. Also, value-added resellers may receive systems, update them, add more equipment, and they may want to provide additional integrity measurements of the system as it was updated by the value-added reseller before it arrives at the enterprise location. And various things along those lines. There are various people who might want to provide measurements along the way. And some of these suppliers might be using different operating systems, different data formats, that kind of thing. And so verifier is likely to be running a different operating system and a different structure, and may just format simple things like, MAC addresses and IP addresses and PCI things and all that just the formatting differences might confuse a verifier. And verifiers from different sources, from different manufacturers, need to be able to make sure that they're getting the same results, and finding a system is valid or invalid. No matter, from the same data, they should come to the same conclusion. Also, how do we store off and safely transmit the golden measurements, and how can we confirm that they haven't been damaged? Do we have security keys for those, et cetera, and on and on and on. There are many complexities here that need to be addressed, and many of them have not been addressed yet. So, quickly, what is TCG doing? TCG working groups have been developing specifications to try and deal with these issues. They've been updating existing published specs to enable the technology. They've been publishing new specs. their scope is how does a platform measure and attest to its code and configurations? How are the golden measurements created and communicated and stored? How to encapsulate measurements to securely send them to verifiers, etc. But they have specifically decided that remediation of systems is out of their scope. They're not in a position to specify how systems are repaired once a verifier's decided that they've been corrupted in some way. So quickly, there's a bunch of specs that you should care about in this space. The PC client platform firmware profile, or PFP, talks about the existing measured boot process. This spec has been updated to reflect changes needed to enable this process that we've been talking about. So the platform firmware profile specification that's out is in a current draft for public review, contains updates to enable this approach. Again, another draft spec is the PC client platform firmware integrity measurement document, and this spec was driven directly from 800-155. It follows along step by step through 800-155, addressing how the guidelines are supported by the various specs that are going to be part of the PC client world from TCG. The server working group has published a firmware profile for BMCs, for management controllers on servers, and how they should be measuring things. That's a bit more constrained environment than full-blown personal computers. So they have specified how they should be measured in a measured boot process. The infrastructure working group has published for public review a document that describes the reference integrity manifest, basically a manifest of all those measurements, the integrity measurements, and how a verifier can validate the expected values, called assertions, against actual values, the evidence, and how they assemble the measurements by different entities in the supply chain into a standardized golden set of measurements. Then PC client, that working group, has taken that reference integrity manifest specification and took the general approach and then specified, okay, for a PC client platform, what do we do here? How do we make this happen? Then the trusted attestation protocol information model from the networking working group shows how attestation evidence can be passed between the attester and the verifier, and it tries to stay away from the specifics of any particular communications protocol. It just has how they can be securely sent from the system being checked to the verifier who's going to check it. There are several other specs, and I really can't talk about this in any detail at all, can't really answer questions about because of the non-disclosure rules of specification working groups. But just to let you know, there's an attestation framework document in work, a general canonical event log format that's going to be published, and mappings from various data sources to measured values. This is things, for example, the SM BIOS spec that DMTF controls provides a good source for platforms to gather data that might be measured. that might need to be measured. But different platforms do it different ways, and so they're going to provide specifications for how to deal with the differences from platform to platform when reading different data sources. Also, I wanted to let you know here, and this, as it says on the slide here, I wanted to thank Ned Smith from Intel and the TCG Attestation group, because they were gathering information about what other organizations are doing. And as you can see from this slide that I borrowed from them, the IETF has been really active in this space. They have produced a bunch of specifications around some of the same topics the TCG is working on. And I suspect that some of them may conflict with one another. So we have active groups working in this space doing a lot of interesting work. And I mentioned several other groups that are also working. Just as a quick aside, the TCG is also working on the NIST Special Publication 800-193, which is the Platform Firmware Resiliency Guidelines. And a quote from that is, protecting the platform against unauthorized changes, detecting unauthorized changes that occur, and recovering from attacks rapidly and securely. That sounds like motherhood and apple pie to me. I mean, it's just like we all want that. But TCG has several groups working on what general platform capabilities are needed to provide resiliency and how to implement the guidelines in 193 and enable resiliency on various different platform types. This is not the same thing as 155. It's a different space, but I just thought I should stick in one slide to let you know this is also an area of interest that you were probably going to care about. So, what's next? What's going to happen from here? Enterprise and government agencies really want this capability. They want us to succeed and get it done. The various TCG groups continue to develop and update their specifications. Many that I haven't talked about will be coming out into public view. Obviously, many other groups are DMTF, IETF, et cetera, all the people on that slide and others are all involved in this, and it's a multifaceted effort across the industry. So all of us in the UEFI space need to be paying attention to this. Don't be blindsided. There's a lot of stuff going on, and if you're not paying attention to it, you need to be. You need to be aware of what's happening. There are many issues remain to be worked out, and this is just a tiny subset. A lot of people are concerned with the brittleness of measurements. This is the idea that that subtle changes to the configuration of a machine that really have no security effect cause PCRs to change, cause event logs to change, which maybe make it hard to verify, etc. There's no clear view of how these golden measurements are going to be created and stored and secured, etc. A lot of work going on in that area, but it's not done. What are the full roles and responsibility of the verifiers, or the MAAs in 800-155 speak? There are many efforts underway in various groups. They're largely uncoordinated. Many of the groups are not talking to each other. So we're going to end up with a lot of published specs that may well be in conflict with one another. So the call to action here is make sure you've got engineering resources in your company assigned to study the effects on your products. And this is particularly true of OEMs and platform firmware vendors, but anybody in our ecosystem needs to be paying attention. Review the specs I pointed out and new ones as they appear, and consider participating. Many of you are already members of TCG, but you don't actively participate in their groups. And having some coordination between UEFI, TCG, DMTF, et cetera, which many of our companies are members of, but the representatives don't necessarily talk to each other. So we need to make sure that we're coordinating these efforts. So we've reached the Q&A part of this. Looking here at what I see so far, how are OEM-specific keys secured? Can they be compromised? I'm not sure how the OEM keys apply in this situation, but certainly in general, in the secure boot case, there is always a problem with OEM supplied keys and how they can be secured, and if they should be accidentally publicized, whatever. But I'm not sure. Maybe we can follow up offline with that one. This document will be definitely available for download on the UEFI website and also via Bright Talk. Also, it'll be available, this whole webinar as is can be viewed after the event by going on to Bright Talk. Yeah, are any vendors offering commercial verifiers? I'm not sure if I have not heard of any. I do know of efforts to create verifiers that are active in the marketplace, but I don't want to speak for companies that haven't given me permission to speak about products that they have in work. So I know that prototype verifiers are being created, and they're finding all kinds of difficulties, honestly, in getting it done because the standards are not complete yet. So, are there working groups considering cloud platform form factors? I'm not sure. I haven't heard of any, but that would be a very nice approach to broaden this out beyond government agencies and specific corporate enterprises to make this more available and have some sort of a cloud-based system that maybe you could even connect your home PC to and have your home PC attest during boot and have some external site that you trust verify your log and your measured boot to see if your system has been damaged and in somehow offer you remediation. That sounds like a service that would be quite useful for somebody to provide. Again, I suspect that we're in an early stage here, and until we really nail down the specifications so that everybody is talking exactly the same language and we get the same consistent results from various verifiers, that will be problematic. But it's a nice goal. Do we have any other questions out there?
We do have one other question here. You mentioned NIST will be coming out with a new document to replace SP 800-155. Will that be an updated version of 800-155, or will there be an entirely new document with a new number?
That's a good question. I'm honestly, I have no say over what the U.S. government decides to do, and they have not committed one way or another. What they have said is they expect to produce a document that up-levels the 155 document to be more general and less specific and give general guidance on what needs to be done and the approach needs to be taken. And then at that point, once they've created that document and they point to the TCG specifications as an approach to a solution, and if anybody else creates one, obviously they would point to that and reference it as well. Then it's really up to them whether they publish a new draft of 800-155 with that new content, or whether they just deprecate that old draft and create a new one with a new number. That's entirely up to them. Any other
Great,
questions or anything else?
We have time for one more. You listed a number of TCG working groups are working on new specifications in addition to the one mentioned here. Can you tell us more about what is being worked on?
Yeah, as I said before, the problem with talking about things that are being worked on is I've gone about as far as I can in saying what's being worked on and telling you, identifying the different areas of research that are going on and documents that are being prepared, because just like UEFI, working groups and their work product is private, and the members are under non-disclosure agreements, then I really can't go any further without specific permission. I apologize for that, but it's just it's the world we live in and the way the specification working groups are generally done. I know that grates against some folks. We want to have a better, more opportunities. But anyway, I can't really talk about it further. I would like to say, though, as I put up on the screen here, some may not feel comfortable asking questions in this particular format on the webinar, but they may want to be able to talk in a more informal forum. So we're going to open up a WebEx immediately following this meeting, and have just myself and you folks, anybody who would like to ask further questions on that WebEx, and I'll do what I can to answer the questions I can during that session. So if you're not comfortable asking questions in this environment, but you're willing to do something in a more informal discussion format, feel free to follow the link on your screen and join the Q&A in the WebEx platform. So for the rest of you, thank you very much, and I appreciate your participating today.
Great, thank you all. We'll see you at the live WebEx.